So I just said our final exam do not have any complex numbers or vector questions. So do not worry about it if you find some of those questions in the final review. Second question, or second announcement. So I received the notification about the timing of the final exam already. So my coordinator told me that I can assign this final exam as a take-home. So I think I will assign it as a take-home. Probably I'll make it due next Tuesday, the end of next Tuesday. Okay, next Tuesday. So perhaps I will assign somewhere around Sunday or Monday, give you 1 or 2 days. I'm not determined. The exam was supposed to be a 3-hour exam. So I think at least 1 day, at most 2 days would be good. Okay, anyone has any question?
Is it still going to be roughly the same format? Like we're going to have like 15 questions of no calculator portion and
Okay,
then
so this time you have more questions, more smaller questions. But
Okay.
the style is very, very similar with what you have done in the previous exams. Very, very similar style. Okay?
And then that's because it covers the whole semester, right?
Yes, correct.
Okay. Thank you, Professor.
Thank you for asking. Anybody else has any question? Okay, thank you, Andrew, for asking this question. What percentage of our grade is it was? So in order to answer this question, let's look at the syllabus. The syllabus has everything you need. So let me open the syllabus and show you where you can find those information on the syllabus. This is our syllabus, our most iconic, epic, wonderful, fantastic syllabus, which you almost never read, right? So look at, this is our schedule. This is our exam days. Okay, so now you see how each part, how many grades are there for each part, okay? Quiz 15, online homework 10%, application project 5%, in-class exam 45%, final exam 25%, okay? So Andre, did I answer your question?
Yes, thank you.
Thank you for asking.
Was the review starter extra credit?
Review starter is our quiz, so it's considered our part of our quiz.
Okay.
So the point why I say that this can be an extra bonus points opportunity is because finishing this quiz is super easy. You just need those questions you have, write them in good writing, okay, in good quality, then you get 4 points. If I see you are writing everything so carelessly, I take some points off. I only take points off if you don't submit or if you don't write things carefully or clearly. Okay, so anyone has any question? Well, great. Very good. So what are we supposed to do right now? I'm going to go through the final review, just like we did before. I'll ask you if you have any question about each question. Okay, so we have 2 classes to review. This is our final review. As you can see, it was an exam in the year 2018, which is almost 3 years ago. Can you imagine the year 2018? Well, the pandemic is nothing but a dream. Everything looks normal. And our favorite Donald Trump is still performing in the White House. Okay, that's just a joke. Never mind. Okay, so let's look at this question. Okay, on the first page of this exam review, does anyone has any question? The first page, does anyone has any question? No one has any question? Okay, so let's look at the second page. Anyone has any question about the second page?
Can we do number 6?
Thank you. Does anyone want to do number 5?
Yeah, could we do number 5, please?
Thank you for asking. Let me grab my pen. Okay. Let me switch the document camera. This is number 5, okay? Number 5. Number 5, what is the value of tangent to 135 degree? How do we find this question? First of all, whenever you are given with the angle, if you cannot see the value immediately, think about how we can find it on the unit circle. Okay, this is our unit circle. So where is negative 135 degree? Where can we find it? So negative means you should go backwards. 135 degree should approximately somewhere here, right? So what is the reference angle? In other words, what's the angle between this angle and this side? So this is 180. So 135, the reference angle is 45 degree, right? Okay, great. You find 35, 45. Once you get this angle is 45. So let's calculate what is tangent inverse 135 degree equal to sine inverse 135 degree over cosine negative 135 degree. Now we can rewrite everything in terms of the reference angle. Okay, so first about this sine. In terms of the 45 degree reference angle, this sine negative 135 should be something like a sine 45 degree, but we do not know whether it's plus or minus. Remember the ATS rule, ATSC rule. Oh,
Yeah,
ASTC.
yeah.
Thank you. So on this side, only tangent is positive. So, but the sine is negative. On this side, the cosine is also negative. So you have sine 45 over cosine 45 degree. Okay, this square root over 2 over square root of 2 over 2, which gives you 1. That's it. Any question? Hello, did I answer all of your questions about this one?
Yeah, you did. Thank you.
Thank you for asking. Let's look at question 6. Question 6 of the review. Question 6 looks very complex. It is this. Such a complex stuff. How do we do with such a complex stuff? So we break everything into small parts. Let me ask you, what is first tangent 30 degree? Okay, can anyone tell me what is tangent 30? Just sine 30 over cosine 30, right? 1/2 over square root of 3 over 2, which give you 1 over square root of 3. Right? Any question? So what is tangent square 30? So which means this guy squared give you 1/3. Okay? So 1/3 for this part. Then what is sine 60? Sine 60 is square root of 3 over 2. So what is sine 60 squared? Is 3 over 4, right? What is cosecant 30 degree? It's 1 over sine 30 degree. So sine 30 is root 1/2. 1 over 30 degrees 2. This guy is 2. Okay. Then the leftover job is adding those 3 terms together and complete this multiplication. So which is 12 times 1/3 plus 3 over 4 plus 2. Oh, no part. Should be a minus here. So if you add the 3 terms together, you should get 12 times, this should be 19 over 12. Eventually you have 19. That's how you get the answer B. Okay, anyone has any question?
You just move the paper up a little bit.
Okay, up. Does that work for you? Hello?
Yeah, it does. Thank you. Okay, I got it. Thank you.
Thank you for asking. Okay, any other has any question on this page? No one has any question on this page? So let's look at the second page, 9, 10, 11, 12. Does anyone has any question?
Could
Yeah,
we
could
go over
question
9?
9? Oh, sorry.
My bad,
No,
my
no,
bad.
we're the same one.
Okay.
Very good. Let's do question 9. So look at this question. What is the range? For every function, we have a domain range, right? So let me first ask you this question. what is the range for y equal to sine x? And we learned that the sine is always between -1 and +1, right? That's how the sine fluctuates, right? Excuse me. So let me ask you this. How about what is the range of 3 times sine x? Since you are times 3, so the area, the values you can take in are extended from -3 to +3, right?
Yes, because that'd be the amplitude, right?
Very good. So what if you sine 4x? It does not matter. Your function just jump more and more, but it still use the same amplitude, right? What if you minus another 4 pi here, another pi here? You're just shifting around, right? Shifting this side or this side. Still jump on the same area. So our answer is this. Okay, that's where the function can take values. No matter you shift it right, left, or jump more often, does not matter. Okay. Does anyone have any question on this one? Okay. So if nobody has any question, let's continue to the next one. Okay, let's look at on this page. Does anyone else has any other question?
Number 10.
Very good. Number 10. What else? How about 11, 12?
Can we do number 12?
Yes. How about 11?
Could we do 11?
Yeah, cool. So let's begin working on it. Question 10. What is the length of the radius of a circle with a central angle of 2 pi over 3 radians? Intercept an arc of 4 pi feet. What does that mean? You know the angle and you know the arc. So previously, when we learned that the arc length equal to the angle times radius, right? This time we are giving with arc 4 pi, angle 2 pi over 3. And you want to know what is the radius. So let's say times r. How do you solve this equation? You divide both sides with 2 pi over 3. Once you finish this division, you get 6 on this side, on this side. So the answer is C. Okay. Did I answer a question about this one?
You did, thank you.
Thank you for asking. Question 11. Find the exact value of sine 33 minus cosine 50 degree. Okay. So this topic is very hard, but you notice a phenomenon. 33 plus 57 is exactly 90. And we have a formula which tells you that sine 90 degree minus any theta equal to cosine theta, okay? which means this is just cosine 57 degree, right? So in the all, this is 50, cosine 50 minus cosine 50, which eventually give you 0. So 0 plus 1 give you 1. So the answer is A. Okay. Did I answer your question about this one?
Yeah, you did. Thank you.
Thank you. And don't forget that at the end of exam, there is a formula sheet which is attached. Okay. Question. Yes.
Oh, real quick, is it gonna be the same one that's on the back of this exam?
Uh,
As it, cause this one only starts with like the sum and difference, and I know that when we did like the like arc angle and stuff like that, it doesn't have it on here. It only has a couple,
you
like
know
more
what?
of the recent stuff.
Let me check it right now. Let me check it right now. Let me check the formula sheet right now. Oh. Ah, you're right. This formula is not on the formula sheet attached with the exam. But I want to comfort you. But don't forget that our exam is a take-home exam. So basically you have every formula available to you. Okay,
Thank you, Professor.
cool. Okay, let's look at where is our exam? Okay, it's here. So let's look at question 12. It asks you where the theta is in which quadrant. So sine theta is smaller than 0. Okay, let me switch to my document camera. Sine theta is smaller than 0, which means on this side, okay, either third quadrant or fourth quadrant, second theta is greater than 0. What is second theta? It's 1 over cosine theta, right? So 1 over cosine theta is also greater than 0, which means, what does that mean? Cosine theta greater than 0.
Wouldn't it be when cosine is equal to 1?
It means this cosine theta
It means it's positive, right?
is also greater than 0. Great. But we know cosine theta is always corresponding to the x coordinate. So only the fourth quadrant is possible. Okay, here x greater than 0, cosine theta greater than 0 on this side. So which means the fourth quadrant. That's it. Okay, does anyone else has any question about this one?
No, thank you.
Okay, great. Let's turn to the next page. Anyone has any question about next page? 13, 14, 15.
Could we go over 15, please?
Anyone want to 13, 14?
14.
Okay.
please.
I'm sorry, what'd you say?
14.
14. Okay, let's do 14 first. Find the reference angle. So when you review for the exam, make sure you understand the most important definitions. Reference angle was one of them, is one of them. So 245 degree, what's reference angle for 245? That means you go above 180, then you go, this is 180, you still need to go another 65 degree more, right? 65 degree more. Okay, so once you get this side, what is reference angle? Reference angle is just angle between this ray and the x coordinate, right? So it's just 65. That's it. Did I answer your question?
Yeah, thank you.
Thank you for asking. Yeah. Question 15. Linear speed of an object traveling on a circle with a radius 5 feet at angular speed 10 pi. So what is the linear speed? In other words, linear speed is just ask you, look, an object is traveling on a radius. You know the angular speed in terms of in 1 minute how many angles it travel, and you also know the radius. So you want to know how long the arc is when it travels in 1 minute. Okay. So the radius is 5 feet. The angular speed is 10 pi. So in 1 minute, just in 1 minute, he travels 10 pi reading. The angle he traveled is 10 pi. 1 minute. The angle he traveled is 10 pi. So within 7 minutes, what's the distance he traveled? The distance, the angle times radius, which is 50 pi, right? Notice that he traveled so much in 1 minute. 1 minute. So the final speed should be 50 pi feet over minute. Okay, you just find how much he traveled in 1 minute, then you will be able to figure out what's the speed per minute. So the answer is B. Did I answer your question, by the way?
Yeah, you did. Thank you so much.
Thank you for asking. Question 16. 16, 17, 18, 19. Anyone has any question about that?
$17.
17. Okay, let me check what is 17. Okay, find the exact value of sine 95 using sum or difference formula. So sine 195 degree, sum or difference formula, which means you have to break this big angle into some small angles. So 195 is sine 180 plus 15, right? So where is the angle is? 180 is here, 15, so you are going a little bit above 15. Okay, the angle is here. So using the sum formula is sine 180 cosine 15. Plus cosine 180 sine 15. So what is the sine value? Sine value goes to 0. So what is the cosine value? Cosine value is -1. So the whole answer turns out to be -15. sine 15, right? So what is negative sine 15? Who knows? We don't know. What is negative sine 15? We don't know. So if this is negative 45 minus 30, which means this is negative sine 45 cosine 30 minus sine 30 cosine 45 degree. Which means negative square root 2 over 2 cosine 30 square root 3 over 2 minus 1/2 square root 2 over 2. So if you factor this is square root 2 minus square root 6 over 4. That's it. Okay, did I answer your question about this one?
You did, thank you.
Thank you for asking. Anyone else has any question on this page? How about 18, 19? Anyone has any question?
19.
I'm sorry, what did you say?
We do number 19.
Very good. Let's do 19. So you are given with a polar coordinate. He wants you to find another set of polar coordinates, such as the radius is positive. Okay. So this goes back to the basic definition of polar coordinate. Notice that our first polar coordinate has something weird. The radius is negative 5. The angle is 6. So in order to get this point, we first need to get a positive point for it, then go backwards. A positive point for it is like this. 5, angle 6, so it's somewhere here. Now you should go backwards. Negative 5, going to this way. So this will be a new terminal point for the angle. How do we find a positive radius for it? Actually, it's super easy. You still use the same radius. Just same radius, but you need to find a different angle. So what is the angle for this guy? This is pi over 6 plus pi, right? So it's 5 comma 7 pi over 6 percent. That's it. Did I answer your question, by the way?
Yes, thank you.
Thank you for asking. Okay. So next page, 20, 21, 22, 23. Anyone has any question?
Can we do 20 and 21?
20 and 21. Very good. Question 20. The rectangular coordinates of a point are given by this point. -1, so the point is somewhere here. Find the polar coordinates of this point. Okay, so in order to find the polar coordinates, you first have to find what is r. So can anyone tell me what is r is? It's just distance between this point and the origin, right? So it's -1 squared plus 1 squared. So square root of 2. This is our radius. So what is r? Look at this map. So this equal to this side. So we want to know what is the angle. This angle, okay. What is this angle? There is something special about this point. It shares the equal distance between x coordinate and y coordinate. X coordinate and y coordinate. So this angle is pi over 4. So the angle is pi over 4 plus pi over 2, which is 3 pi over 4. That's it. So the polar coordinate is square root of 2, 3 pi over 4. Okay. Did I answer a question about this one? Hello?
Yeah, thank you.
Thank you for asking. Okay. Anyone else has any question on this page? 21, 22, 23?
We do 21.
Yes, 21, what else? Okay. So here's a very important thing. Maybe you joined this Zoom session later. Let me switch to myself. Question 21 is about complex numbers. Let me announce this again, just in case some of our students join this Zoom session late. We do not have any exam do not have any question related with complex numbers covered during this semester. We do not have any question about it in the final exam also. Okay, I checked the final exam already. Don't worry about complex numbers, no question about it. Okay, so we can skip question 21. Okay, anyone else has any question about other questions on this page? Okay, how about next page, 24, 25? Actually, they are all complex number questions or vector questions, so we can also ignore them. How about the part 2, short answer questions? Anyone has any question about short answer questions?
Yeah, could we do 2 and 3, please?
2 and 3. Establish the following identity. Write each step in a separate line and show all steps that need your solution. Clearly label any identity that you are using. Establish the following identity. Write each new step in a separate line. Okay, so let's prove that this is true. Okay, so on the left side, you have this. What is this? It is cosine theta, sine theta, cosine theta, 1 over cosine theta, sine theta. So we need to merge those two fractions. How do we merge them? We make them share the same denominator. On this side, you multiply with sine. On this side, you multiply with cosine. So this side you have sine squared. This side you have cosine squared. Once you do such a merge, you see sine plus cosine. What is sine plus cosine? Just 1, right? So what do you get? 1 over sine. What is the definition of 1 over sine? Just cosecant. Okay. Hello, did I answer your question?
Yeah, you did. Thank you.
Great, thank you for asking. Okay, anyone else has any question? Question 3, question 4?
Could we go over 4 as well, Professor?
Oh yeah, great. How about question 3? Anyone want question 3?
Yes, please.
Yes, please.
Okay, so let's look at question 3. Solve the following equation on the interval. So our equation is 2 sine theta minus 1 equal to 0. This is our equation. So how do we solve it? Sine theta in your eyes should be just a number. We don't know what this number is, but we can try to isolate this number out. The first thing you do is moving everything to the right side. The second thing you do is divide everything by 2, just trying to isolate. So you see, sine squared is 1/2. So what is sine theta? Square root of it. But you can do it plus or minus, right? So which is plus minus square root of 2 over 2. So sine theta have those values. What are the angles? Again, you turn to unit circle for help. So this is one of the angle. This is another angle. This is the third angle. This is the fourth angle. So within 0 and 2 pi, you have so many angles which quantify. So which can be 4 pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. Okay, those are the 4 angles which works. Hello, did I answer your question about this one?
Yes, Professor.
Okay, great, thank you. Let's look at question 4. Okay, question 4 has so many parts. So which part do you want me to do?
Could you go over C?
Great, thank you for asking. So question C want you to find cosine to theta. You have such a great formula. Okay. Then you just plug in what you have here. So it's 1 minus 2 square root of 5 over 3 squared. 1 minus 5 over 9, which is 1 minus 2 over 9, which is negative 1 over 9. That's it. Okay, understood. Did I answer your question?
Yes. Would we also be able to try it with like 'cause I know you use the 1 minus 2 sine squared. Could we try it using the 2 cosine squared of theta minus 1?
Very good. You can also try that one. They should be equivalent. But for this question, we are giving with sine. We are not giving with cosine, so that's why I use
Oh.
sine.
Oh, okay. I didn't see that.
Okay, great. Thank you for asking. Anyone else has any question? Okay. So how about next page, question 5? Anyone has a question 5, question 6?
Those are complex, right? So we're
Oh
not
yeah, we should ignore them. How about question 7, question 8?
We did question 8.
Yeah, could we do question 7 too?
My pleasure. So question 7, sketch the function for at least one period and state the amplitude, period, phase shift, and vertical shift. Label at least 5 important points on the graph. Okay. So label at least 5 important points. How do we do? Instead, we start from the beginning to see what it looks like for cosine x. Cosine x looks like this, right? How about this question? First, let's see, what is 2 times cosine x? I think we should not begin with 2 here. We should begin with 1/2 here. So what is cosine 1/2 x? We can still use the same graph, but we extend it. Make sure it looks longer. Okay. So let's say, for example, originally you have this point. This is your 2 pi. So now what is this point? It's 4 pi. Originally this is a pi. So what is this point? It's 2 pi. Okay. So we change. Next step, we are making a function which is more similar with the function we need. So what is this part? I'm just making interval part the same. This is just the same with x plus pi, which means everything plus pi move to the left by pi units. So this is pi. So if we move to the left, so now you should be on this pi going up. So now originally it's pi, now it's becomes 0. Originally this 2 pi becomes pi. 4 pi becomes 3 pi. 0 becomes negative pi. Okay. So the next question, we are 2 times this function. We should make 2 times cosine 1/2 x plus pi, parentheses 2 times this guy. So which means we amplitude everything by 2, which you give. So move down 2 units, going up 2 units. So originally you are taking, this is 1, this is -1. Now it becomes +2, -2, because everything moved 2 units. The last step is we add 1 to the bottom, plus 1. So everything move up by 1 units. Okay, so you pass through the origin here. Now you should pass through 1 here. That's it. Every point move up 1 unit. So this point should be -1. This point should be 3. So that's the 5 steps we get to this graph. And I omit many details. For example, I should add plenty of points in each step we move, okay? So that you can know where the points are. But to save time, I didn't add that. But I'm sure you can add it. Okay, anyone has any question about this one? Hello, did I answer your question on this one?
Yeah, you did. Thank you.
Thank you for asking. Okay, just be careful, each step by step. Question 8. Use a graph the polar equation. So what do you mean by saying use a graph? It means that we can get the values from the graph. Okay, let me ask you, you should make a table. 0, when x is 0, what is y? When x 0, y is 2. Look at the solution key. I'm just copying what is on solution key. When x is 6, pi over 6, what is y? Y is 3. When x is pi over 2, what is y? Y is 4. When x is 5 pi over 6, what is pi? 3. So blah, blah, blah. I just write down 4 points as an example. You can write more points if you want. So how to draw the polar coordinate? Remember that all of them are in polar coordinates. The first is the angle. The second is how far or the radius is. So the polar coordinates look like this. When x 0, when the angle is 0, it means you're on this side. You should travel 2, let's say 2 is here. This is the first point. Then you begin your travel by finding another angle. When your angle is pi over 6, the distance is 3. So distance 3 should be on the third circle. The angle is 3, distance 3 is here. When angle is pi over 2, the distance should be 4. So it's on this angle. So you can continue this process. And what is 5 pi over 6? 5 pi over 6 is the angle is here and the distance is 3. So you can continue to mark all the points, find the angle, find how far it is from the origin until you can make a whole circle. Then once you find all the points, like this, then you can connect those points with a smooth curve. So someone asks you, how can I make a smooth curve of it? So let me tell you the trick. The trick is that you learn from the graph of the textbooks and the graph from the formula sheet or the lecture notes. Once you look at the graph more often, you know how to draw them. Just like once you look at the eggs more often, you know how to draw the shape of the egg. If I just say egg, I didn't tell you what it looks like. You know it's like an egg like this, right? This is too awful, but just imagine it as egg. So the key is read the graph from lecture notes or textbooks more often. Then you will be able to draw the functions graph. Okay. Did I answer a question about this one?
Yeah, you
Hello?
did. Thank you.
Oh, thank you. Thank you for asking. I'm kind of tired. Okay, let's see. We have the calculated part. Okay, does anyone has any question about the calculated part? I think question 1, 2, 3. Anyone has any question about the calculated part?
Yeah, could we go over question 3?
Very good. Again, a surveyor measured this is question 3 of the calculated part, which should be page 18 of the PDF. A surveyor measured the formula in order to find the width of a pond showing below. So the graph looks like this. A, B, C. Find the width of the pond. So we know AC is 245.3. We know BC is 211.9. We know the angle C is 27.4. So you can use a law of cosines. Law of cosines says that C squared and equal to A plus B squared minus 2AB plus cosine C. So A is this value, B is this value, angle C is this value. So you can plug in to find all the values. Then you get what is C equals to. C equal to, according to the answer key, should be somewhere like 12 thousandths. Then you take a square root, you should get 113.04. Round to the nearest number, it should be 113.0 feet. Do not forget the unit. Okay. Hello, did I answer a question about this one?
Yeah, you did. Thank you.
Thank you for asking. Okay, how about question 4? Yeah, question 4 is last question on this review. Anyone else has any question 4? Okay, so it seems that nobody has any question about question 4. Let's go back to myself. Okay, we finished this exam review already. So we are only 15 minutes to the end of class. I feel I'm kind of very tired here because I'm keep talking. Next class, which is our Thursday is our last class. I will look on your quiz 8, which you submit about your questions, and try to make some explanation toward every question you submitted there. Okay. So anyone has any question? Okay. So let's stay here until 9:15. Stay here until 9:15. I will take attendance thing. So if you want to talk with me anything, if you want to ask me any question, feel free to ask me right now. Okay? Do not go. Stay here until 9:15. Feel free to ask me any question.
Thank you.
Thank you. Do not go, I said. Do not go. Come on.
I
Time
think
is
you're
up.
muted,
Feel free to
Professor.
go.
Thank you.
Bye bye. See you on
Thank
Thursday.
you. Have a good one.
Thank you.
Thank you.
Professor.
Bye.
Thank you, Professor.
Hi, Hussein.
Hey, I have a
Andrew, is
question.
anything I can help you?
I have a question.
Yes, please.
So you mentioned the complex question is not it's not on the exam, right?
Yeah.
What is like require the calculator? It's not on the exam.
I'm sorry. Can I speak slowly?
What do you mean like complex question when you say?
So on the exam review, we have a few complex number questions.
Oh,
Complex number questions, not a complex question. They're different.
okay.
Okay. Don't worry about it.
All right, thank you.
Okay. Anything
So
else?
exam's next Tuesday, right?
Yeah.
All right, thank you.
Okay. Goodbye.
See ya.
Hi, Andrew. Andrew. Andrew, is anything I can help you?